You know, for centuries, some of the absolute sharpest thinkers have tried to crack the case of the human mind. They've followed these brilliant leads, uncovered some incredible clues, but that central mystery, how does a physical brain create a conscious thinking self? That's remained unsolved. So today, we're reopening the case files. We're going to treat this whole intellectual history like a detective story. We'll track the clues each major theory found and the walls they all inevitably hit.
Okay, so let's just dive right in. This whole investigation, it's not about trying to debunk these incredible theories. Not at all. It's about seeing what pieces of the truth they managed to uncover, because every single one of them gives us a piece of the puzzle. The story of why they failed, well, that's actually the blueprint for a solution.
So, it's time to meet our lead investigators. You can think of them as different kinds of detectives, right? We've got the meticulous logicians from the early days of AI, the big-picture functionalists, the super-precise mathematicians, and, of course, today's heavy-hitting data crunchers. Each one followed a really compelling lead, a totally unique angle on how intelligence actually works.
In our investigation, it spans the better part of a century. It starts back in the 50s with this idea of the mind as a computer. Then it moves through these fascinating theories of consciousness, and it all culminates in the incredibly powerful deep learning and predictive models we have today.
So our first detective, symbolic AI, it found this massive clue. A lot of our thinking really does look like we're just manipulating symbols. Systems like ACT-R could model stuff like arithmetic with millisecond precision. But they hit a wall, a big one. These systems can follow rules perfectly, but they can't ask why they chose one rule over another. It's kind of like that famous Chinese room argument. The system can shuffle symbols around to give all the right answers, but it doesn't understand a single word of the conversation. The key here is they have absolutely zero self-awareness.
All right, next up, global workspace theory. Its clue was this brilliant metaphor. Consciousness is like a theater stage. Information gets broadcast from this stage to a huge audience of unconscious modules in the brain. And this beautifully explains the flexible but also limited nature of our attention. But it leaves the biggest mystery completely untouched. It explains the function of the broadcast, sure, but not why the lights are on in the first place. Why isn't all of this complex information processing just happening in the dark, without any subjective feeling at all?
Detective number 3. Integrated Information Theory, or IIT, came in hot with this really bold mathematical lead. It basically proposed that consciousness is a quantity called phi, which measures a system's integrated information. The more a system is both unified and complex, the more conscious it is. But this clue, as elegant as it sounds, it led to a dead end. Turns out, calculating phi for something as complex as a brain is, well, it's computationally impossible. And maybe even worse, a major study in 2024 designed to test it found that its key predictions just weren't seen in the brain. Ouch. And that brings us to our most recent detective, the absolute powerhouse of deep learning. The clue it found is just undeniable. These layered neural networks are incredible pattern recognizers, but their success hides a really deep flaw. Think about it. A large language model can talk all day about the taste of coffee, but it has no tongue. It's what we call a function approximator, just learning statistical correlations from data without any genuine understanding of the world behind that data. It can perform, but it doesn't comprehend.
Okay, so let's just step back from the individual case files for a second. We've seen a whole series of brilliant detectives. Each one uncovered a vital clue, and yet each one hit an insurmountable wall. A symbolic mind that can't know itself, a global workspace that can't explain feeling, an information system we can't even compute, and a deep learning brain that doesn't understand anything. You see, these aren't random failures. There's a pattern here. There's an invisible thread connecting every single one of these cases.
So what is it? What's the one thing that connects all of these different dead ends? What is this invisible wall that every single one of our brilliant detectives ran headfirst into?
It all comes down to the problem of self-reference. Each of these frameworks, in its own unique way, completely failed to account for a system that can model, monitor, and reason about itself. Think about it this way. You don't just feel sad. You can know you're feeling sad and then wonder why you're sad. That capacity for self-reflection, that is the missing piece of the puzzle.
But look, this isn't just a story of total failure. One detective got so close. This approach, it's known as predictive processing, and it followed a clue so powerful it nearly cracked the entire case wide open. It shifted the whole focus away from logic or consciousness directly
and onto the fundamental act of prediction.
Now, the core idea here is a complete 180 from how we normally think about perception. The brain isn't just passively soaking up data from your senses like a sponge. No, instead, it's actively, constantly generating predictions about what its senses should be experiencing. It's basically building a model of the world from the inside out.
So here's how this predictive loop actually works. From the top down, your brain sends out its predictions, what it expects to see, what it expects to hear and feel. Then from the bottom up, your senses report back, but only on the errors, just the difference between the prediction and reality. And the brain's entire goal is simply to minimize that prediction error over time, constantly updating its internal model to be better and better.
And this leads to a seriously mind-bending conclusion. What you experience as reality isn't the world itself. It's your brain's best guess, its generative model of the world. It's a kind of controlled hallucination that's constantly being reined in and corrected by those little error signals coming up from your senses. Wild, right?
So this is by far the most successful framework we have for explaining perception and learning. And yet, it still slams right into that same invisible wall. Standard predictive processing is great at explaining how the brain models the world, but it doesn't have a built-in mechanism for how the prediction machine models itself. It is missing that final, crucial, self-referential loop.
So where does that leave us? Do we just throw out all the old case files and start from scratch? No. The solution isn't to come up with yet another competing theory. It's to build a synthesis. There's a new framework called Frequency-Governed Self-Graph Reasoning, or FGSGR. Now, that's a mouthful, I know, but what it does is it takes all the clues uncovered by our detectives and finally puts them all together.
What FGSGR does is it builds a complete architecture by combining the best clues from our entire investigation. It uses rhythms, brainwaves or neural oscillations, to organize everything in time. It uses graphs, just like the ones from AI, to represent structured knowledge. It uses probabilistic inference to handle all the world's uncertainty. And crucially, it builds in those self-referential loops that allow the system to actually model its own processing.
So this synthesis, it kind of closes the case on these older theories, but it opens a brand new, even more profound line of inquiry. By combining structure and learning and prediction and that crucial self-reference, we finally have a blueprint for a mind. The question is no longer just how do our minds work, but what does it mean to build a new one? What happens when a machine built on all these principles finally comes to know itself?